All right, welcome back to Autodesk Digital Builder Podcast. I am your host, Eric Thomas, and I'm excited to get all into some really incredible AI-related research. And to help me tell that story, I'm joined by Dr. Fope Bademosi, the construction researcher and educator at Autodesk, and Lorenzo Villaggi, a principal research scientist also here at Autodesk. I'm going to read their bios today. I normally don't do this, but both of them are doing some really cool stuff, and I want to make sure everybody knows that. So Fope is a circular economy and construction researcher here at Autodesk. She investigates construction sustainability, net zero practices in the industrialization of construction. She has over 8 years of construction industry experience, specializing in global challenges. She has a PhD in design, construction, and planning with construction management concentration from the University of Florida. She was an assistant professor at Wentworth Institute of Technology, and her research integrates circular economy principles with construction practices to advance industry sustainability. A mouthful, but a very cool one at that. And on top of that, we've got Lorenzo Villaggi here. He's a principal research scientist with the AEC Industry Futures Group. In addition to that, his work focuses on reusable design intelligence, AI, and sustainability for AECO. Recently, he's focused on new AI applications to promote building and material research. And recent projects include a net zero carbon modular and affordable housing development in Oakland, California, an engine for Airbus in Hamburg, and the Almater Affordable Housing District for Van Wingen in the Netherlands. You're giving me all these words I don't know how to pronounce correctly,
but I'm all wrong.
I'm trying my best over here. It's all good. All right, so let's get things started before I power through more and more bios. I think I've hyped you up sufficiently, but before we get going, how you guys doing? You feeling good now that I butchered your research names?
Feeling good. Thanks for having us, Eric.
Yeah, thank you for coming back. This is your second time on the podcast, so the first time must not have gone that badly.
It was a good one.
Yeah, we had a really good time with Evan Riley, who was at Skanska at the time. But let's get into all things research. So to get us started, Fope, can you tell me how the Autodesk research team operates and the type of work that your team does?
Yes, absolutely. So Autodesk Research explores how technology can be applied to emerging design and make challenges to prepare our industries for the coming future. So what's unique about our approach to research is our teams are working 5 to 10 years ahead in the future across all the industries that Autodesk serves. Lorenzo and I are representing the AECO industry. And we work with a diverse range of stakeholders, both internal product teams as well as external collaborators. So, for example, we have the Autodesk Research residency program that houses this community of innovators from academic, industry, and entrepreneurial sectors. And this, I think, allows us to cross-pollinate ideas that end up being applied research projects that we could work with industry partners on to be able to prove and test our workflows on actual construction and design challenges. And the Autodesk Technology Center is where these research projects come to life. Actually, the project Lorenzo and I are going to be talking about was done at the Boston Technology Center. And we're part of the Net Zero Buildings team, where we're currently researching how we can, leverage new technology to improve and advance net zero buildings in the next decade.
I love it. And the real world application of everything you're doing in making sure that the research and the efforts really actually show up on site. I think it's a really unique and impactful approach. And I'm very grateful for the work that you're doing. Lorenzo, anything else to add as far as the full scope of what your team's doing?
Yeah, I think Fope has said it all, but I do want to stress how unique of a position that we're in and privileged by thinking about, so far ahead in the future, but having the possibility to test this directly with customers and being right there in the industry, doing research on the field and trying to find where the friction emerges when you test new technology that may not have been tested before out there.
And you're really on the bleeding edge. And so it's really cool that you get to step in and go, okay, help us figure out how we can be better. How can we augment this to really apply to the work that folks are actually doing or you're anticipating they'll be doing in 5 to 10 years, as you pointed out. So let's go a little bit deeper. Can you get into what exactly you're speaking about this week and what about your research is so exciting?
Yeah, I'd love to introduce some of our work. So We've been thinking a lot about AI for net zero buildings in the past years or so. One way to achieve net zero carbon buildings is to reuse as much as possible materials and buildings. So to promote reuse, we developed two new AI innovations. One is about AI to assess existing buildings by leveraging limited and multimodal data. And that comes with deriving also an inventory of reusable materials with attributes like how much carbon is avoided, the potential financial value. And then the other AI innovation involves AI agents working together to develop low carbon wall assemblies from a mix of reclaimed materials and new materials. And we're very excited to be showcasing this at AU.
Before we take a closer look at some more of this research, Fope, I was hoping you could tell me what inspired this direction of research into AI, specifically for reuse and circularity in architecture. And can you explain what the concept of circularity is, or the circular economy, for those that might not be familiar?
So as we've already mentioned, we're a net zero buildings team and we focus on sustainable research. And the reason is because buildings and the construction, the built environment contributes about 40% of the global carbon emissions. And this is a huge number. Aside from that, also 90% of waste generated from construction ends up in the landfills. And 75% of those materials could be reusable. So we're also just wasting resources out there. Research as well as practice has shown that reusing existing buildings and the materials that are in them can avoid carbon emissions by up to 50 to 75%. So that's the good news. We as an industry just need to, change our practices and our mindset so that we're actually targeting those numbers. So this is where the circular economy comes into play. So the circular economy concept pretty much takes us from transitioning away from the traditional take, use, dispose linear model of operations to a more regenerative approach. So what this looks like is, instead of demolishing buildings, we assess the building, we take a look at what is available, what can be reused, refurbished, or repurposed. But the goal is to dispose of as we should avoid that as much as we can. So always think first of reusing, recycling before you dispose of anything. And even if you do, what are some ethical ways of doing that as well? And our research, as Lorenzo says, is sort of looking at new methods to sort of help with that. And not just that, working with existing buildings is known to be notoriously difficult, right? You obviously might not have all the information that you need. Typical assessment methods would look at scan photos, so you can take pictures or point cloud information about the space, but that only shows you what is visible. You don't get the full picture. You don't see what's hidden in the walls or in the ceilings. That's, was the impetus of our research. So how do we develop new AI technologies that will help us not only see the hidden aspect, but get a full inventory of the materials in the existing buildings, and also the conditions and what can be reused, and then use those for new designs.
Yeah, I think we've all been beholden to opening up a wall if you're a homeowner or a contractor and go, surprise, what is in here? And that doesn't feel good. And at scale, it becomes an even increasing problem. And as you pointed out, most of these things just find their way to the landfill. And so I'm thankful that you're looking closer into how we can more effectively operationalize the process of actually effectively reusing materials and identifying them, because in today's current market, it's inherently difficult. The process is not linear. It's often an afterthought, and the ability to step in and go, this is what's here. This is what we can reuse. How can we make this easy and cost effective for everybody, instead of a giant hassle or potentially an increase in cost to really step back and evaluate all that. And I want to jump into this X-ray tool that you're looking at first. And Lorenzo, I think you're smiling because you saw how excited I got when we first were chatting at our kickoff call when you were telling me more about this really innovative technology. So tell me a bit more about how it works and what it's like using it when you're out in the field to assess what, actually is in the walls of these existing buildings.
Yeah, totally. I'm smiling because I think we are also personally very excited about this. And as we've been showcasing this to customers, to real experts out there in the industry, we love seeing their reactions. And that is bringing a lot of enthusiasm in our team. So we have a little prototype that has been built on a tablet that allows users to see in real time by pointing this tablet onto an existing wall to literally see the things, the materials, the components that are hidden within the wall. Exactly like almost like an X-ray like vision. So we can start pointing out at different systems that we didn't think were there and start thinking about potential reusability paths for each of these materials that we see. Would you like me to talk about how this works?
Yes, please.
Yeah,
It's so cool.
Yeah, so what we're showing here is just the final step of this AI tool that predicts what is inside the wall. So that's the result of a custom large language model workflow that we devised, and that's the final output. But to get there, we mix limited and multimodal data together. And this is data that is generally typically available with existing buildings projects. So for example, we can include GIS information. And with that, I mean data that is generally publicly available, like where is this building located? When was it built? Is there any renovation history that we can tap into? How big it is? How many floors? What is the use? So any kind of context clues that would be even helpful for an expert contractor to guess what is behind that wall. So we're trying to do the same with this large language model. And on top of that, we can pass historical floor plans if the owners of the building happen to still have them, like scan drawings or other kind of digital formats. And then on top of that, we can input, let's say, the holy grail of working with existing buildings. So point cloud data, which again, as Fope said, is incredible, but by itself, it tells you only a small picture. It doesn't give you the full picture, let's say, of the whole problem with existing buildings. And then on top of that, we can add a sensor-based readings like thermal imaging or radio frequency-based readings. And what we noticed in our experiments is that by increasing the diversity of modalities of data, so different types of data, we're seeing a loose trend of improved accuracy of our predictions. So in a way, this is showing us that working with limited and multimodal data could be an alternative to the typical uses of AI that generally involve a lot of data of the same type. And we're very excited about this path.
It was so neat when you were showing the demo of this to me, where like somebody's literally just holding up an iPad. And of course, on the back end, you've added this data already and informed it, whether it's local building codes or existing scans. So it has that information. And you're literally just holding it up and pointing it at different areas of the wall. And it's repeating back to you what it assesses is in there. And then it also shows the level of accuracy it assumes that it has as well. And it's incredible because you can assess how confident you feel based on the information that's in front of you in a way that, like, the X-ray vision, I think it's just the best descriptor for what you have. And obviously, we're not legitimately looking through into the wall, but it feels like what you have is a fairly accurate representation of what's probably in there. And you can make a lot of decisions on how you proceed based on that analysis instead of just, all right, well, knock open the drywall and see what surprises in there, which is not an effective way to demo something, especially at a huge level of scale. It's just very cool.
Absolutely.
I want to hear a bit more about if somebody actually has this in their hands now, like what benefits do you anticipate this will bring to a construction project from them using and implementing it? Like, what's the long-term ROI you're going for?
That's a very good question. I'd like to add that this is just one step in a bigger pipeline that we envision to help architects and all the stakeholders involved with existing buildings projects to promote reuse. So we start with step one, predicting what is inside walls or the material composition of an existing building. From there, we derive an inventory of materials, just like Fope mentioned earlier, that includes all the different materials that can be recovered, including the avoided carbon and other metadata. And then we have this other part, which is about what do you do with all this stuff? So you can start designing low carbon assemblies that involve reusable materials. So with all of this in mind, we believe that this can really help us achieve our goal, which is ultimately helping architects achieve low carbon futures. That's our ultimate goal. So how do we do that? We do that by presenting all of this comprehensive information as early as possible in the design process. So as you mentioned earlier, Eric, often this could be an afterthought, thinking about, oh, we could include that, we could reuse this. So instead of doing that, we're trying to push this as early as possible to give all the stakeholders involved in the project as much information and help them make more informed decision to make circularity and the reuse of materials and components an integral component of the project.
Yeah, this is a culture shift. This is a mindset shift and an adjustment in processes. And I feel a lot of folks aspire to this, but they haven't had the means historically to integrate it into their process in a way that didn't feel cumbersome or complex or potentially adding additional costs elsewhere to actually go through and assess and figure it out. And so it's cool that you're really putting the research in place to hopefully achieve that future that you're looking at. And it's an impactful goal and an incredibly important one.
We also see a future where the research can grow, where the tool becomes used on projects and it's able to also predict and identify the presence of hazardous materials. So we're talking about old buildings that have been around before lead and asbestos were forbidden. That could also evolve into a tool like that. So the health and safety of construction workers is also taken into account and they don't have to be exposed to some of these materials if it can be avoided.
I love that because the process for figuring out if your insulation or tile or whatever is, chock full of asbestos is an onerous one and requires testing and time and cost there. And so if you can be a lot more certain before you step foot in the building, what are we dealing with now? To your point, one, safety. You're not breathing in asbestos. You're not dealing with any of these materials. But two, there's a cost savings there as well because you can be a lot more reasonably certain about what materials you're dealing with.
Yeah, absolutely. By knowing ahead of time the cost implication, the carbon implications, you can just make more informed decisions. And I want to stress the fact that this is not a solution that is put on you. The human is very much in the loop. We are enabling users to really navigate this delicate phase of balancing trade-offs. So by exposing cost, by exposing total carbon, because you're looking at avoided carbon, we're looking at the savings in embodied carbon. You're also looking at operational carbon because the final step, the design step, provides suggestions of wall assemblies with R values. So you have the full layer of the wall assembly so you can start thinking about full life cycle assessments and really look at the full carbon picture of what you might design.
I love it. There's a lot of really goodness mixed into everything you're talking about. And I think it's going to push the industry forward. It's really cool. Fope, so I'd like to get more into our AI for low carbon assemblies aspect of your research. And I know your team has developed an AI system for this process using refurbished materials. Can you walk me through how that tool works and what you found during this part of your research?
Yes, so Lorenzo started to mention that. So that is the step 3 of our workflow, where we're leveraging AI to be able to generate and design low carbon assemblies that integrates these existing materials that we've identified and cataloged in the inventory. So the way it works is the user prompts the AI agents and they put in their design intent. So it could be based on whatever is most important to the owner or the architects or the designers. And they also input their project requirements. They're able to specify the performance that they want the assemblies to reach. So everything is prescribed. And this is a multi-step agent process where I think we have 4 AI agents that are working together. You have a supervisor agent, a research agent, the designer, and such. And based on the user intent, the project requirements, it comes up with the best possible new design for you that integrates some existing materials. But we also know, of course, for a new project, you also have to include new materials. So it could be new construction materials, but we are promoting low carbon sustainability materials. So the tool also plugs into several databases like 2050 Materials and EC3, where you're able to see the EPDs of new sustainable materials like mycelium facades or cork as well. And it also gives you all the information like the carbon calculation, the performance ratings, and all of that. So it gives you different options. You're able to pick what's best for your project. We're currently showcasing 3 examples based of our experiment. So the first one is about maximizing reuse of the existing materials as much as possible. The second one is about thinking of deconstruction in the future. So how do we design for disassembly at the end of the life cycle of the building, for example? And the last example we're showcasing focuses on the integration of biomaterials together with these reclaimed materials. So having a mixture of both. But yeah, so that's how the design process works. So again, I think if you were to do this traditionally, it takes a long time. So it's not easy to integrate old building materials with new ones or swap out high carbon materials for low carbon materials. There's a lot of research that has to go into place. There's a lot of considerations with the building codes and constraints. So the AI agents take in all of these factors, they do the research, and they present to you options, and you can pick what's best for your project. So this is an iterative cycle. It's not final. Again, the decision lies in the hands of the designer.
I love what you're talking about here, though, because it puts access to so much information in a nimble way that historically hasn't been possible. And I love how you're describing the ability to merge both the old and the new, where previously the amount of research and manual processes that would have to happen to get there are considerable. But the other really exciting thing to me is just this agentic focus now, because it changes how people build buildings. It changes how we actually interact and interface with our tools, because now you're becoming a prompt engineer. Now you're telling it what you aspire to achieve, importing all this information in a way that historically a tool just didn't exist to allow you to do this. It was very manual. You had to have a lot of knowledge and education to even consider this. And so I'm very excited, as you can likely tell at this point. You're both doing some incredible research here. Can you tell me a little bit more about what kind of constraints fit into this, like local building codes as example? Like what else can the system account for?
Yeah, so to your point, local building codes. So you put in, your project information. It makes sure that, whatever specifications are being provided to you sort of ties into the building code. And also part of that is the performance requirements. So you have information regarding R value, for example, or fire rating of walls. So that is also incorporated. I think it's important to mention that, even though from step one, even though we might identify materials that are reusable, doesn't mean that we should reuse everything. So we need to know what is actually reusable and meets all codes and performance testing and metrics. So it does all of that research. I think that's what the research engine particularly is for, to make sure that it's compliant, it's standard compliant. I think it looks at like the UL standards as well as the Building Green Advisor standards as well. So it correlates every specification with codes, material standards, as well as safety, I believe, standards as well, just so we're not reusing things that shouldn't be reused.
It makes sense. And I'm sure it makes it easier to also present multiple different options as well, where you go, okay, well, let's see how much we can reuse. All right, maybe this isn't the most effective way. Let's pull this back a little bit. And you can be quite strategic, but imagine trying to manually do all of these different options as well. I feel like the speed to which making decisions here is impacted in quite an incredible way. Yeah. Not just one choice, but like a multitude of options because of all the information that it has access to.
Yeah.
I love it. Lorenzo, can you tell me a bit more about how this actually works under the hood? I'd love a high level explanation. I'm sure if we get too deep in the weeds, we're all going to get a little bit confused, or at least I probably will. But I'd love, maybe give me the 15,000 foot view of what we're looking at here.
Yeah, I'll try. I'll do my best. But just to build off of what Fope has been saying, this is a very exciting step of our workflow where we have a team of agents that are tasked with specific roles. We have a supervisor agent, we have a research agent, we have a design agent, and we have a validation agent. So once the user inputs a design intent, like for example, I want to reduce cost and maximize the reuse of the existing materials that we supplied from the harvested materials from the existing wall, the supervisor tasks the research agents to crawl the web and make research about potential new materials that could be included in the assembly. They crawl the data set from 2050 materials, that report is passed to the design agent that starts designing and creating sequences of materials put together. And then this is tested against the constraints of local building code, the design intents from the user by the validation agent. And all of this happens in an iterative process where they keep talking to one another and eventually come up with one solution that the user may review. What I love about this workflow is that not only, as you mentioned, Eric, the users are becoming prompt engineers, and that may seem very new, but in a way, it's very similar to how we work right now. We're just really interacting and collaborating with the machine. We are agents, we're human agents working with machine agents. And there's a way to get back the result from the agents, and we can say, I'd like to swap this with something less carbon intensive. And the agents go back to work. So it's a very interactive and seamless workflow, puts out there this different way of working with AI as well. Instead of being a black box where you push a button and you get a result, you see the actual process under the hood. And I think that is transparency and exposing the reasoning behind these AI processes is something very exciting and new as well.
It's so interesting. And correct me if I'm mistaken, based on the way you prompt this, do different agents within the ecosystem end up having more priority based on the output? So if the query you're looking for is more research intensive, this one's going to have way more input, or the supervisor. If I'm way off base, you're telling me.
Yeah, no, that's a good question. I'm not sure if there's some hidden hierarchy between the agents that takes place during the design process, but it's definitely a complex task that takes a significant amount of time. It takes so much expertise. Because another thing that I didn't mention is that these agents work with different kinds of knowledge graphs. And knowledge graphs are simply just a way to encode data in a structured way. They work with material knowledge graphs where every node corresponds to a specific component or material, and the edges of these graphs that connect different nodes embody meaning and relationships. For example, this drywall sheet is fastened to this stud. But expand this to the tens of thousands of materials that we have at our disposal, thanks to the 2050 materials collaboration and all the other standards that we're looking at. We also have knowledge graphs for assemblies from the UL standards and the knowledge graph that we're passing from the existing building that we mined. There's so much knowledge. So we're empowering these agents to extract knowledge from these databases and help us make better decisions.
I could ask you guys questions about this for the next 2 hours. And so I'm going to wrap myself up here because I know you have a busy schedule as well. But I want to know what's next. So Fope, how do you take what you've achieved so far and where are things heading? I'd love to hear a little bit more about where you're going.
Yeah, so for the past year, we've been really in heads down at the Boston Tech Center, testing this out on mock-up walls, but we're actively exploring a customer collaboration to test out this with a case study, which is what we're showcasing, which is an office to data center conversion. So that's exciting because, as I mentioned in the beginning, our goal as Autodesk Research is to do applied projects with customers. So that is happening. And we're excited for that because that would give us more feedback and help us with improving the tools as we go along. And then, as Lorenzo also mentioned, the more data we have available to us and we feed that to the AI agent, the better the prediction is. So we're currently working on testing out other modalities of data as well to help with improving the accuracy of the predictions. But also with step 3, just improving, we want to expand to more assemblies. So we've been focusing on wall assemblies because of our case study, but we also want to expand to different building assemblies, see what could be generated using the materials in the inventory. So still a lot of work to do, but yeah, we're excited and we're looking forward to seeing where this goes. But also just again to mention, as Lorenzo said, having feedback here at AU and the enthusiasm that we've gotten from customers, and everybody's like, yes, please continue. So I think that's good, energy to go home with and continue this. Before we wrap up, can I just shout out to our colleagues that are not here? So this research is really just based on a lot of really good and smart and intelligent people from different disciplines and backgrounds. And even though they are not here today, we're really proud of the work that you're doing, and we just want to thank them for all the work and effort that they've put into this.
Yeah, absolutely. I mean, this is very clearly a team effort, and I'm always excited when I get to visit the tech center and check out what you guys are doing, because there's just so much happening. And please don't stop. Like, keep going, because like, I'm not surprised that folks here at AU, when they get to see what you're doing, are responding positively, and it's incredibly impactful work. So before I let you get back to your day, I've got one more question for each of you. Lorenzo, I'm going to throw it your way first. What is one tool you use on every project, no matter what you're working on?
I'm old school, pencil and paper.
All right. Are you like drafting table and everything, or where does
I
this go?
procrastinate a lot, so I need to scribble random things.
And off the list.
That too, but just random sketches. And a lot of, jokes aside, a lot of these problems for me personally can be solved visually. Like, I just need to visually represent what I'm thinking, even if it's like hand palm sized little sketch. That's really helpful for me.
Nice. I like it. Fope, how about you? I don't remember how you answered the question last time.
I remember. I think I said something like, curiosity and adaptability, but I don't
Good
think
answers.
that's changed
All right.
much. I think especially with the pace everything is developing these days with the AI tools, and then the fast pace that the construction industry is moving as well. I think still just being curious and being willing to learn new technologies and techniques and adapt as they evolve is really important for me.
It makes sense, and I can see why you landed on the research team. Well, thank you both so much for sharing your knowledge. As you can see, I'm excited. I'm not surprised other people are as well. I look forward to bringing you back on and learning more about what you're working on next. Everybody out there listening, of course, I'm your host, Eric Thomas. You are listening to Autodesk Digital Builder Podcast, and you can find us on YouTube, Spotify, Apple Podcasts, or anywhere you get your favorite podcasts. And until next time, goodbye.